Alright, so good day everyone. This time we are going to talk about problem solving and search. So we have uninformed search and informed search algorithms. So uh, for our previous lesson, we were able to have or discuss about the PEACE framework and how to formulate a problem. So in a PEACE framework, we have the performance measure, which tells us how success is being evaluated. So in our example, the self-driving car, so we can evaluate success by safety in our environment. This is the context in which the agent operates. So it could be the GPS maps, okay, where the self-driving cars will be deployed, right? Actuators, these are tools or actions available to the agent. So we have the steering brakes, and we also have the cameras or LiDAR and sensors. These are how, or this is how the agent perceives the environment. So whenever a sensor detects something, so the actuators react. So in this case, we have cameras or LiDARs as example. Now, how do we formulate problem? So first is we have to have an initial state and then actions that will be done after that state, and then the transition model, how will the agent react or yes, how will it react or move, and then what is the goal of that agent and how much path cost will it take. So this afternoon or this day, we are going to learn about, or you will be able to explain the role of search in AI problem solving, differentiate BFS, DFS, and A-star algorithms in terms of strategy, complexity, and optimality, apply BFS, DFS, and A-star to simple problem scenarios, and of course, evaluate the trade-offs between uninformed search methods and informed search methods. So for the first slide, we let's talk about its definition. What is search? Now, in reality, before when we search something in a dictionary, right? So we would like say, for example, we want to search the word discuss, and to search for the word discuss, we will go directly to letter D in the dictionary, right? We will not go over to A, B, C, D. This is what we do. So this is the process of exploring possible sequences of actions to reach a goal from an initial state. Its importance in AI is that it's foundation for planning, pathfinding, and decision making. So again, there are two classifications. We have the no domain specific knowledge. We have the BFS or DFS as an example for uninformed, and the uniform cost search as well. For informed demand, we have heuristics like A-star algorithms, and these are sourced in the books shown below or authors shown below. So the components of research problem, we have a state space. The state space are all possible states reachable from the start. Then the initial state. So we have here an example of an initial state. For example, in a maze, right, we all start with something. So say this is the starting point, okay? And then we want to go to the goal test, which is the goal, okay? So what are the actions, no? These are the legal moves from a given state. So for example, we can only move from these states here. Hence, we put letters or classifications to it. So these are the states that we would want to go. For example, from the goal state, from initial state, our goal is to go to path E. Now, that is the goal test, right? And to know the path cost, we would know how much or how, for example, ilan yung meters na na-travel ng isang intelligent agent. So, once again, let's go back to the different types of search algorithms. We have uninformed search and informed search. So, on this part one of the video, let's talk about the depth first search and the breadth first search and the uniform cost search, which is under uninformed search. And on the next video, we're going to talk about the informed search, which are the greedy search, A-star search, and a graph search. First example, But before that, let's first define what a USA is, or the uninformed search algorithm. It's also called blind search. It explores the search space without any domain-specific knowledge. So it treats all nodes equally. So what does it mean is that it doesn't care which path it will go, as long as it will just follow the algorithm that is it will follow the algorithm, whatever it is. So, for example, if it's a depth first search, okay, so it's based solely on general rules. So, as mentioned earlier, it follows the algorithm or the rules that it gives. So, for example, in the depth first search, we have here, let's check if it's recording. All right. The depth first search explores paths by going as steep as possible along one direction before backtracking. It uses a stack or recursion to keep track of the path. So DFS is memory efficient compared to the breadth-first search since it doesn't need to store all siblings at each level. However, it's not guaranteed to find the shortest path and may get stuck in an infinite loop if the search tree is deep or contains cycles unless depth limits or visited checks are applied. So say for example we have this path and our initial state is this S right here. And our goal is to reach for any of the letter G or the goal states that is available here in the nodes. So we have nodes S, A, B, C, D, and G. Okay. And uh, just to let you know or inform you, these are called nodes. Okay. And then any nodes have their children. So in this case, the children of S is A and D. The children of A is B. Children of B is C and G, and G does not have any children, so it's called the leaf. So any nodes without children, they are called the leaf nodes. Okay. Now we would want to go to from S to node G in this graph, and how do we do that? How is this path SABCG being found? Okay, so for the depth first search, it just traverses to the as mentioned earlier. It traverses or explores paths by going as deep as possible along one direction muna. So, let's say for example, the node S is its first is its initial state, right? And node S has its children A and D. So as mentioned, the first search would want to traverse first to the path that is on this that is will explore path by going as steep as possible in only one direction. So let's first start, unahin natin si A. Okay? So si A, so after visiting S, we have A, D as the children, and now we visit the leftmost, which is A. A has a children of B, right? And we have unvisited node of D here. And then we visit the leftmost, which is B. Okay? B has a children C and G. And then we have not visited D, so let's put that because we can visit that later on if walang G dito, no? Then afterwards, we visit letter C or node C, and then node C has a children G, right? And we have not yet visited G on the G of children B and D, okay? Of siya D, hindi natin na-visit si D. So, we have already visited G, right? We can already visit G. Since this is the first G that is going to be visited by the path. So therefore, our path would become S to A to B to C to G, and that is our path. I hope that is clear. Now let's have another example of the depth first search. So say you have S going to G. We only have one goal state here. So earlier we have multiple goal states. So whichever one will be visited using the DFS, kung sino yung first ma-visit, yun yung ating path. So here we only have one. So let's do what I did earlier. So node to visit first. No, this is the node, and this is katong children niya. So children has A, B, C. So si A has a path 3. We can write that or we can. Pwede na. Because in that first search, wala siyang pakialam sa path cost. So, but we can write it because it's given B1 and then C8. So, as mentioned earlier, uunahin niya muna yung one direction as deep as possible. So, of course, we will visit A3 first. Si A, meron siyang children na D, E, G, right? That's D3, that's E7, and that's G15. But it has not visited B1 and C8 as well, yet rather. So, next, since it's going to visit the deepest node in one direction first, it's going to visit D3. So after visiting D3 node, children, so it's now going to, let's write para di tayo malibog, E7, G15, C8, and then let's visit E7. Still, there is no children of E7. And now, since after that, after visiting E7, we can now visit G15. So, we have P1 and C8 as our unvisited nodes right here. Now, therefore, we can say that our path is SAG, right? This is our path because we cannot go to SAD, walay padulungan na G. SAE, dili pa te. SAG is our path. And our cost is 18, right? That's 3 plus 15. So therefore, from S to G, that's like 18 meters, for example, in Google Maps, or 18 kilometers. Now, that is the path that is going to be visited using the depth first search. I hope that is clear for you guys. Okay, next in our example, we have the breadth first search. The breadth first search is a fundamental search algorithm that explores all possible paths level by level. It begins from the root node and explores all neighboring nodes before moving to the next level of nodes. So what does it mean is that kanina, we have nodes right here, right? It will visit first yung TFS. Uunahin niya visit yung first one direction lang, as deep as possible. Si breadth first search, it will visit here first, and then here, and the next levels, and the next level. So this is their difference. So BFS is complete and guarantees finding the shortest path if each move has the same cost. However, yung drawback niya is high memory usage as it stores all nodes and at the current level before moving deeper, which can grow rapidly for large or complex problems. Say, for example, masyadong mataas yung tree mo, diba? So, if that happens, i-store niya isa-isa yung mga na-visit niya na node. So, hence, its drawback is this one, high memory usage. Example, so what is the path to get first to the goal states that we have earlier using depth first search? Ito kasi nga, di ba, ito yung i-visit niya. But for the breadth first search, sa node S, his children is A and D, right? So, i-visit niya si A. Okay? Si A has a children B, but hindi pa siya tapos nag-visit sa isang level of the node. So, dito natin ilagay si B. Si D rather. So, we will visit D right after. Okay? And then si D, my children siyang G. And then, hindi natin na-visit si D kasi later pa siya i-visit because that's on the third level of the tree. Next is, we are going to visit G, and G has no children, so we have found the path. So, we have S, D, G as our path. So, this is how we write it step by step, okay? For example, sa exam, no, I would want you to write the path so that I would know that you really know how the breadth first search works. Another example, okay, from this node here, we would want to go to node any node G here, or the first G that we can find using the breadth first search. Sure ako, pag na DFS, this is the G that is going to be visited first. So that's A, B, D, C, G. However, in a breadth first search, what will happen is that, say, we visit first node A. Node A has children B, C. So of course, we would visit B afterwards kasi yung pinaka left, 'di ba yung una? Same dito, pinaka left. So B is being visited, tapos si C hindi pa na-visit, but B has children's D and E. Okay? So, visit muna natin si C. Okay? Si C may children siya na DG, but hindi pa na-visit na DE. So, unahin natin yung DE, then si C may DG na children. What's next is that we are going to visit D. Ito muna na D. Kasi tapos na tayo, check, na-visit na. Next, we are going to visit this one. So, si D, may children siyang C and F. So, as you can see, may CF dyan siya. CF. Tapos, hindi pa natin na-visit yung E, D, G. So, okay, andito na tayo. Next, we are going to visit E. Okay, wag muna tayo mag-visit dito, no, si CNF later na. Unahin muna natin itong dito as mentioned that in the breadth first search, by level yung pag-visit sa node. So pag-visit natin sa E, wala siyang children, but we have not visited D, G, C, F. So we are going to visit D, and then after visiting D, we have found out na meron siyang children na BF, but we have not visited yet G, C, F, B, F. So, lastly, we can now visit node G. So, therefore, our path would become ACG, right? So, the path would be ACG. So, this is how we find G or the goal state using the breadth first search, level by level. Once again, you have to know how the path is being found. Baka may ipalagay ko yung table during the exam. Okay, so you can watch this video link. I will upload this in your BPL on the usage of both BFS and DFS in real life scenario. Lastly, the uniform cost search. It's similar to BFS, but it takes the cost of each move into account. It always expands the node with the lowest cumulative path cost from the start. This makes UCS optimal and complete and useful when actions have different costs. Like for example, in navigation systems, it uses a priority queue to manage the frontier and ensures the cheapest path is always chosen next. So here, meron siyang path cost. Okay, we can see that in uniform cost search, nga may path siya, diba? So from S to A, 1 siya. S to D is 5. So of course, it will travel first to the shortest. Which one among the child or among the nodes has a short path? So, of course, it will travel. So from S, na siya children na A1, D5. Tapos, traveling A1. So, si A1, of course, wala na ilain, no? A1, so may next kay A1. B5, ito si B5. B5, tapos, B4 pa di ay, A1. Mag-visit kay A1, siya B4, tapos mura siya. That's only the children, but we have not visited B5. So we compare between the two. B4 is shorter, so we visit B4, of course. And si B4, we have children C, C5, G5, and not visited B5. So, directly, we can visit G5 na, no? Instead of going to C because same cost sila, but it's useless to visit C. This uniform cost search. So now you can visit G5. So the path would be SABG. Okay, so let's have another example of the uniform cost search in this medyo complicated na example. So, say for example, the cost so far is 0, and from C to B is 2, C to T is 1, C to O is 3, C to E is 2, and C to P is 5. So, what will happen? First is we visit, of course, the parent node, which is C. That is the initial state. C, padulong sa Z na goal. So, sa node C, una na to siya, step by step is we have to like write the shortest one, that is si T, then si B. So kung parehas sila, E ug si B ug si E, parehas ng number, unahon nimo ang pinaka-left. Si B2, then E2, then O3, then P5. Okay? So this is the in order arrangement of the nodes using uniform cost search. So of course, we visit P1 because it's shorter, or it's the shortest among the nodes that we have. But P1 does not have any children, and there are nodes unvisited here. So we write B2, E2, O3, P5. Now let's visit B2. Si B2, meron siyang children na ARS. So, ARS. Okay, that's A1. Meron natin ha. A1. Tapos E2. Next is O, O3. S3. R4, and P5. As you can see, what I did is just um, I'm arranging the path that is from the very least path cost up to the largest path cost there, right? So when I visit A1, okay, walang children. So ay unahan sa nato ni sila ang mga children. Sige. Now let's first write this again. Sorry. So that is B2, we have A1, R4, S3, tapos that's E2, O3, P5. Sorry, no, we can, unahin natin to siya because mag-traverse pa tayo dito. Si A1 would have walang children, so let's go to R4, S3, E2, O3, P5. And then next is R4, no children. Just write everything na nasa left. Then afterward, S3, E2, O3, P5. Okay, now the next one. Among the three here, which one is the shortest? Of course, we have E2. So E2. And then E2 has children G5, right? So G5, O3, P5, G5. Sorry, G5. Wala si G5. Kaya mo man yung children. And then visiting G5, wala siyang children. So we write O3, P5. Now, of course, among O3 and P5, CO ang pinaka the lesser path cost. So we visit O3, and then O3 has children, I1, N2, and P5. So after that, I1 is lesser, I1 visit, and then si I1, meron siyang children na Z2. Z2 and 2P5. Okay, so we have found the goal, which is the Z2. Okay, so we have visited Z, which is the goal. Therefore, the path becomes CO And then you have I, which is the visited node, papuntang C. So that's poise. But the cost would become C3 plus 1, that's 4 plus 2, that is 6. So this is how we do the uniform cost search. So that will be all for the part 1 of this video. On the next part, we are going to talk about the informed search algorithms.